In order to determine the PCR of an airport or airfield, we must start by defining the properties of the pavement structure for which we want to conduct the analysis, namely the number of pavement layers, the materials that were used to build the pavement and of which each layer consists, and also the mechanical properties of the layer. So in the particular case of the pavement that is being depicted in this particular area of depth, we have an asphalt concrete layer, a granular base layer, and a granular sub-base layer with these specific mechanical properties and these specific layer thicknesses. Assuming that we have an expected traffic mix that is composed by this list of aircraft models and their associated number of expected departures from the airport, what we have to do next is define a number of analysis settings, such as the lateral wonder, which is basically just another measure of the standard deviation, the number of traffic cycles per departure, which is a parameter that is associated with the layout of the airport or airfield itself. And if we wish to conduct an analysis for a total period or based on the first year of a period. In this case, this expected traffic mix, the departures already correspond to the total period. But assuming that these departures would correspond to the first year, I would have to select this option here. Then I would have to define an expected growth per year, growth of the number of departures, and the span of the evaluation period. And depth, if I use this option, depth would automatically calculate by itself the total number of departures for the entire evaluation period. But as in this particular case, I'm already considering a number of departures that corresponds to the total evaluation period. I'm going to select this option here, and then the span becomes 1, because it's just one period, and the growth per year is 0, because all of those considerations have already been factored in to these numbers that are presented as expected departures for the total period. So once I have the pavement data defined, the expected traffic mix defined, and the analysis settings defined as well, all I have to do is go to the Analysis and Results tab, select the PCR button, and after a few seconds, DAPS will provide us with the results for its analysis of the PCR for this particular pavement structure and expected traffic mix. What DAPS is telling us is that for these conditions, the PCR code is as follows. We have the numerical value 540. We have an F for flexible pavement, because the pavement that we are considering consists of a flexible pavement. So F is for flexible. C corresponds to the category, to the subgrade category, and is determined by the subgrade modulus. So to a modulus of 90 megapascal corresponds a C subgrade category. Then we have X, which is the code for the inflation pressure, and T because it's a technical evaluation. DEPS is also telling us that the maximum damage to the pavement structure occurs at a distance with an offset of 5.37 meters in regard to the center line of the runway or taxiway, for example, and that the cumulative damage factor, CDF, corresponds to a magnitude of 3.98, which is the same thing as to say 398%. So this pavement is either under design, this particular pavement structure is either under designed for the expected traffic mix, or the traffic mix demands too much of the existing pavement structure, and we are going to have to condition the aircraft that use this particular pavement structure in order to keep the structure with a controlled damage level. And we can see that it's clear to see that the damage caused to the pavement is higher than 100%, because in this summary table, for each aircraft model we have an ACR and a PCR, and it's easy to see that the PCR is always lower than its correspondent ACR, and this happens in cases in which the damage is higher than 100%. If the damage was lower than 100%, the PCR would always be higher than the ACR. And we can also see that the highest calculated value for PCR corresponds to the aircraft model MD-11 with a calculated value of 543 that rounded corresponds to this number here, 540. If we wish to visualize the evolution of the damage in the pavement section in regard to the distance to the center line, we can select the damage option, and DAPS automatically presents us with this particular graphic, in which we have in the vertical axis the damage calculated in terms of percentage, and in the transverse axis we have the horizontal axis, we have distance to the center line in meters. So we can see that each of these distinct lines that are being represented in this graphic correspond to the individual damage caused by each specific aircraft model. And then we have this black interrupted line that corresponds to the sum of all the damages caused by the different aircraft. So this black interrupted line is the total damage. And we can see that the total damage has a peak of approximately 400%, which corresponds to this number here, 398%, and that the peak damage occurs at a distance of which is a bit shy of 5.5 meters, and if we want to define it numerically, more specifically, corresponds to 5.37 meters. So this information here that we can see numerically, graphically corresponds to this point here. So you have a distance of 5.37 meters and a maximum damage of almost 400%. If we wish to visualize the coverage map that corresponds to this traffic mix, we can also use this particular option here that says coverage map, and we will be presented with a similar graphic as before, but now instead of damages we see the number of coverages that each aircraft will have on each section of the pavement as a function of the distance to the center line. And we can also see that the aircraft model that will have a higher number of coverages will be the B737, which is represented with this dark red line here. And although this is the aircraft model that has the higher number of coverages in this pavement section, it is not by far. It's by far not the model that is more demanding of the pavement structure, and this happens because if we visualize a 3D representation of the vertical strains on the top face of the subgrade, for the B737, we can see that the maximum magnitude of the subgrade strain is approximately 1200 microstrain, and we can also see that the main landing gear is composed of two wheels, but these wheels are disposed transversely, so they are side by side. So each time that a wheel passes, the peak value of approximately 1200 microstrains will only be achieved once, while for the airplane MD-11, if we visualize the exact same graphic that corresponds to a representation of the vertical strains on the top face of the subgrade, we can see that the maximum strain this time is above 1800 microstrains, and that due to the arrangement of the main landing gear, the peak value is achieved twice. So every time that the main landing gear passes over a specific pavement section, the maximum peak strain on the subgrade will be achieved twice. So it's the combination of the number of coverages that a particular aircraft model has on a pavement section, and the effects that its load causes on the pavement structure, namely the strains, in this case for PCR, only the strains in the subgrade, on the top face of the subgrade, that factor in to cause the total damage. So we must not think that just purely simply because one particular aircraft, in this case the Beech 737, has a much higher number of departures than the MD-11, but we cannot purely simply assume that just because this particular aircraft has a higher number of departures than all others, that this will be the most damaging aircraft. So we have to be careful in regards to that. We can visualize the subgrade strains for any aircraft that we have in the list. For example, for the B767, either in 3D representations or as well 2D representations, which will provide us with exactly the same graphic, but just in a slightly different format. We can easily copy this graphic to Excel, to Word, to any other software that we would like to use, and we can also copy the summary table that has all the information that we require. Using this copy to clipboard button, we can also copy the entire summary table to Excel, Word, or any other software.